No! Were any of you guys like this, trying to figure this problem out? Because that was definitely me when I tried it for the first time. So I just wanted to give you a quick backstory on why I chose this problem. So back in 2017, when I first started this concept of Math Challenge, I decided to rent a space at an education conference. And next to my booth was this whiteboard that I had with the same exact problem on it. And a lot of teachers went by and they were like, wow, this is a cool problem. And they tried solving it. A lot of teachers tried using the trigonometric functions. I think it's like law of sines, law of cosines. It's a little bit too complicated for me. Or square roots or any kind of higher order math skills to try to solve this problem. And they got very stumped on it. So I know it's a challenging problem, but it's a 6th grade math problem, so no trigonometry or no even square roots yet. So I just can't wait to share it with you guys. I think this is why geometry and math is so fun. So without further ado, let's get our pencils out, thinking cap on, seatbelts fastened. Let's go for that math ride. Woo! So in this problem, we want to figure out the area of Isosceles Triangle DCE. Just a quick reminder that the area of a triangle can be found by multiplying its base times the height divided by 2. Now, if you start off with the clue that's given in the problem, it says quadrilateral ABCD is a parallelogram. So if AB is equal to 6 centimeters, that means DC is going to be parallel to AB and also be congruent, so that would be equal to 6 centimeters. If DC is equal to 6, because DCE is isosceles and it's marked, CE is also going to be 6 centimeters. So if CE is going to be the base of the triangle, then we need to know the height. I'm going to go ahead and drop the altitude there and label that point F. We need to know the height of DF in order to find the area. Now, if you notice, point D is along the same line as point A. So if we drew a line anywhere from line AD down to the bottom of this trapezoid, it would have the same height as DF. So if I go ahead and drew a line straight down to line BC, I'm going to go ahead and label that point G. AG is going to have the same height as DF. Now let's focus our attention on this triangle to see if it could give us any clues. Now we know that BC is equal to 10 centimeters, but because we don't know the height, I'm not sure if that could help us here. But if you notice, ABC is a right triangle. So if AB is equal to 6 centimeters, we can say that that would be our base. And AC is 8 centimeters. That could be our height, because this is where the perpendicular angle is. So we can say that the area of triangle ABC is going to be equal to 6, which is your base, times your height, which is 8, divided by 2. So the area of triangle ABC would be equal to 24 square centimeters. So I'm going to write 24 square centimeters right here. So that's the area of triangle ABC. Now let's go back to the line segment BC on the bottom here. Because now we know the area is 24 square centimeters, we can use BC as sort of our new base and say that the base times the height of AG divided by 2 is equal to 24, and find the height. So if we do that, we can say that 10 times H divided by 2 is equal to 24. If we do some algebra here, I can multiply the 2 to both sides. So 10H is equal to 48. So our height would be equal to 4.8 centimeters. So 4.8. From there, I think the final step is pretty straightforward. We now know that DF then is also going to be 4.8. So the area of isosceles triangle DCE can be found by the base, which is 6, times the height, which is 4.8, divided by 2, which is equal to 14.4 square centimeters. Wow. What did you guys think about the problem? I hope you guys liked it. As a teacher, I feel like these are the types of problems that really make geometry fun. Please stick around for the joke of the day. Thank you so much for watching, and I'll see you guys next time on Math Challenge. Bye-bye.